Hello. So today we're gonna discuss graph traversal. So there are two types of traversal in graph. That is, first is breadth first search (BFS) and the second is depth first search (DFS). So in this video we're gonna study DFS. So before studying DFS, if you are not aware of graphs and how to represent graphs, please go and study that, then come here. So today we are going to perform DFS in a undirected and weightless graph. Okay, let's start. Suppose in this graph we start with 0. Okay, we are at 0. Okay, there are two paths we can go. So let's go with 1. So we reached 1, then we reached 3. There are no vertices connected. Now we come back. Okay, we come back to 1, then we come back to 0. Okay, now 0 has another path, another vertex connected 2. Okay, so now from 0 we move to 2, and from 2 there are two paths. We can go to 4. Okay, now 4 has no connected vertices, so we come back to 2. Now after we came back from 4 to 2, we have another path, that is 5, so we go to 5. Okay, now we don't have any connected vertices to 5. So what do? We go back to 2. Okay, then we go back to 0. So we traveled this path, then this path, then this path. So we can write it as here. Here we can write 0, then we move to 1, then we move to 3. We came back to 0, then we moved to 2, then we moved to 4. We came back to 2, then we moved to 5. Okay, this is one possible travel path. Now there can be multiple paths, like suppose we from 0 we can go to 2, then we can go to 4, then we came back to 2, then we can go to 5, then we all the way went back to 0, then we can go to 1 and then 3. So from 0 there can be so many paths, from 2 there can be so many paths, from 4 there can be so many paths. So many paths can be possible. Okay, now let's do the algorithm. Now if we have to travel a path, there are two representations of a graph. So one is adjacent matrix and one is adjacent list. So we'll use adjacent list for this graph. We can also use adjacent matrix, but for now, for simplicity, we can use adjacent list. So we can make the adjacent list as, okay, I can make okay, so for adjacent list, 0 is connected to 1 and 2. Okay, for 0. Now for 1, 1 is connected to 0 and 3. Okay, for 2, 2 is connected to 0, 2 is connected to 4, 2 is connected to 5. Correct? Okay, so now for 3, 3 is connected to none but 1. Okay, 3 is connected to 1. And for 4, 4 is connected to, we can see 4 is connected to 2. 4 is connected to 2. Correct? And yeah, for 5, 5 is connected to 2. So now let's move to the algo part. Okay, so what we have done is we went from 0 to 1 to 3, then we move back to 0. We didn't move back to 1 then move to 3 1 3 1. We cannot do this. right? So in the algo, we have to keep a record which makes sure that we don't visit the same node again and again. So we make a array, visited array, right? We make a visited array that keeps track of which nodes are visited and which are not. Okay, so for this graph, let's draw 0, 1, 2, 3, 4 and 5. Correct. Now let's define a function which takes a node. Okay, which takes a node, which takes a graph, and which takes a, yeah, the visited array. Correct. When we reach a node, we mark it true, obviously. So we mark visited node to be true. Correct. Now for the node is true, now we have to traverse the neighbors. So for each neighbor, what do we do? If the neighbor is visited, we don't uh, recursively traverse. If the node is not visited, right? If the node is not visited, then we traverse again. So then we call the function again, which is recursion. So we pass the neighbor here, then graph, and then the visited array. Correct. Okay, so for this one, let's try run for this graph. So suppose we start with 0. Who are the neighbors of 0? 1 and 2. We start with 1. Okay, first we have to mark 0 as true. Correct. 0 is true. Now the neighbor is 1. Correct. So we mark 1 as true. So now we are at 1. Yeah. So who's the neighbor of 1? Neighbor of 1 is 0, which is already marked 0. Neighbor of 1 is, again, the second neighbor is 3. So we pass DFS function. We pass 3 into the DFS function. We mark 3 as visited. So who are the neighbors of 3? 1, visited already. We move back to 1. Correct. Okay. Now once neighbor are complete, now we move to 2. So who are the neighbors of 2? 0, already visited. 4 is not visited. We go to 4 and mark it true. Correct. Now who are the neighbors of 4? 2, which is already marked as true. Okay, so we come back to 4, then we go to 5. Correct. 5. So who are the 5 is visited? No, 5 is not visited. We mark it true. Okay, so then we move to 2. So 2 was already marked true. Correct. So here we can see we marked true to all the nodes. Correct. This is how we traverse in DFS. Correct. Now this is the pseudocode. So if we code it in Golang, you can see it is like this. The DFS function, we pass the node visited graph is a 2D graph, then a Boolean array. Okay, this is a 2D array, this is a Boolean array. We mark the in the visited array true, whichever node is visited, for each neighbor of the graph. If not visited, we mark it. If not visited, we traverse with DFS again, so recursively. So this is how we traverse in DFS. Thank you for watching this video. Hit like and subscribe for more.